Hi, this is Scott doing my 577 presentation. Um, this is part three, and I am on slide 8. One thing that I wanted to mention was a whole assumption that I did in this presentation was to use the and leverage the IP network in this country as well as the IP technologies that are available in this country. And I think I looked into research and that indicates that's a good assumption because there's a lot of experience that we have with IP based traffic, and as a result, we're quite good at it. So there does exist the enough ability within the IP area to provide what we need for a smart grid. So with that said, what are some of the security issues for the grid? Because really, this network security is a big part of the challenge for the smart grid. First is that enemies must not be able to read or interfere with the data. And then I wanted to talk about one another assumption I've made for the presentation, and that is that IPsec is assumed to be the primary vehicle for providing secure end-to-end communication, and that I was actually able to find a lot of actual literature on using IPsec in the smart grid. So I feel fairly comfortable with that. And the reason that IPsec was being selected was because it's a very mature system, and it's also it's optimized. It's very efficient. So let's go on to slide 9. What are some of the challenges for IP sec? And this is a big issue for the smart grid because one of the premises for the smart grid is that the technology has to be unbreakable. It has to be last 50 or 100 years. And what that's saying is that you have to have a long lifetime for what you're developing, and that's certainly not normally the case in most of what we do in computers today. I mean, most of what we do in computers, after 3 years you buy a new one, and that it can't be a design assumption for the smart grid. You have to be able to build in advance of what you need or anticipate what you need. And so one of the issues is that some of the cryptography algorithms are expected to be obsolete by 2030, and that would mean that would not be a good choice for the smart grid because you can imagine the immense amount of investment in something as large as the electrical distribution grid. It's a real challenging design environment because you do have to understand that you're leveraging a huge investment, and if you get something wrong or if it becomes prematurely obsolete, it's a big issue. Okay, so let's go to slide 10. What are some of the ethical considerations for the grid? Well, I already mentioned this a little bit. Data privacy and as well as security on the grid. You don't want to be sending control messages to some sort of control switch that shuts off power. One of the main lines. You wouldn't want to have that on the grid and have someone be able to intercept and modify that control message. So it's a challenging environment. So let's go to slide 11 now. Now this is where we're going to start talking a little bit about trust. Because one of the things that's central to the smart grid is you're going to have a lot of different systems on there that need to share with many different systems, different types of data at different times, and all of that traffic has to be able to be, you need to be flexible. You need to be able to let new systems on. You need to be able to take systems off. You need to be able to manage all of these systems so that you've got a replacement if one goes down. It's a very challenging environment. And so what I found in the literature was that the public key infrastructure is a good way to leverage these needs. And there's a lot of discussion about public key, and in fact, it's not actually it can't be the final step. It won't give you everything that you want, but it's a good basis for the trust. And so what I mean by trust here is authentication, that you know that this machine that you're communicating with is a machine that you think it is. And if you can imagine, without authentication, it would be a huge challenge to be able to. It would basically render IPsec useless, because if you're trying to set up secure end-to-end communication and you don't know who you're communicating with, it's of no value. And PKI is mature and optimized, and the great thing about it here is that it's scalable to a massive number of machines. So let's go on to slide 12, the value of PKI. Without PKI, chaos will ensue or an enormous burden will emerge for management of static keys. And the nice thing about PKI is that when you know, put it in place properly with the right tools, it can manage all of your keys in a consistent manner, so that your certificates are expiring at the right time, and all of those things, sorts of things, it forces you to pay attention to them and properly manage them. And the other value is that you're going to have systems and users across the grid. They must be able to access and provide secure services across a vast array of business and control systems. So you need a lot of different people communicating on the grid, and you're going to have different specializations within the grid, where you're going to have plants, you're going to have the systems for metering, you're going to have billing systems, and they're all going to be interlinked to a certain degree, because they all need to communicate. So that is slide 12. Let's go to slide 13. Now, slide 13 is just illustrating that point for you. You can see that you're going to have all kinds of different systems communicating on the smart grid, and they're all going to need to, at some point, have the ability to trust some system from within those different groups and communicate with them. So you have customers, you have distribution nodes, you have transmission nodes, you have bulk generation nodes, you have operations, you have service providers, and you have markets. So that is the end of this portion. I appreciate your patience with having to restart these. They have a limit. So let's go on to slide 14.